welcome to Rico Kongsager's PhD defense. My name is Birte Holst Jørgensen, and I'm Deputy Head of Department of DTU Management Engineering. I want to welcome the Assessment Committee, Professor Dr. Daniel Murdiyaso, Center for International Forestry Research in Indonesia. Also welcome to Associate Professor Christian Pilegaard Hansen, Department of Food and Resource Economics from Copenhagen University. And the chairman of the committee, Senior Researcher Eva Nygaard, UNEP DTU Partnership. Also welcome to the supervisors, Anne Olhoff, UNEP DTU Partnership, Head of Program, and also Professor Ole Mertz, Department of Geography, University of Copenhagen, Denmark. Also welcome to the audience. We are happy to see so many. And last but not least, welcome to you, Rico Kongsager.
Thank you.
A key person of this defense. It is so that Rico will first give a presentation of his thesis. It will last approximately 45 minutes. Then we'll have a short break, and then the assessment committee will put some very challenging questions to Rico. And afterwards, if you as an audience also want to put some questions to him, please notify me in the break. Yeah, and with that, I will give the floor to you, Rico.
Thank you. Yes, good afternoon and welcome, and thank you for coming to my defense about linking adaptation and mitigation with a special emphasis on agriculture and forestry, and it's all taking place in the tropics today. And you here as an audience today, you are a bit of a complex entity, so I'm trying not to be too technical or nor too layman in this presentation. This slide to start with is just to show you that we are dealing with a highly complex system, and we have the adaptation and the mitigation on the top here, but it's highly complex, and that's just to remember, important to have in mind during this presentation, because I'm trying to simplify this system very much. The outline of today is that first I will clarify the definitions of adaptation and mitigation, and then this will be followed by an introduction of the subject. And then I will give a brief conceptualization of linking adaptation and mitigation. And then I will turn the focus towards the 4 papers that are included in the dissertation, and then I'll round off with my conclusions. The definitions on adaptation and mitigation. Yeah, first of all, mitigation and adaptation are 2 primary instruments in the International Climate Convention to minimize the negative impacts of climate change on humans and ecosystems. They both represent responses to climate change, and they are driven by the same problematic, but they have fundamentally dissimilar approaches and have essential differences. For instance, in regard to their specific objectives and time dimension, scope, and level of cooperation that is required. Mitigation is anthropogenic interventions to reduce the sources or enhance the sinks of greenhouse gases, and it's focusing on the causes of climate change, and it's an indirect damage prevention, and its actions taken to reduce the extent of climate change and to avoid the unmanageable. It could be to substitute with fossil fuels with renewable energy, or to reduce deforestation. Adaptation, on the other hand, is the process of adjustment to actual or expected climate and its effects. And it's a direct damage prevention, it's managing of the unavoidable, and it's actions taken to reduce the impacts of climate change and also to avoid the adverse impacts of climate change. It could be to construct dikes or build houses on poles to prevent flooding or to adapt to flooding. This is also seen in a broader context or with a broader definitions, where it's a broader range of actions that make societies more robust to changes, including but not limited to those caused by climate change. And with this last definition, the adaptation is getting closer to and having greater overlaps with sustainable development, and vice versa also. And and there's also many factors that are impacting on the different communities that are not only related to climate change. So that's why we use this wider definition. I have used this wider definition in the papers here. So the objectives of this dissertation was to explore and assess the scope for the current practices and of linking adaptation and mitigation in agriculture and forestry in the tropics. So here are some 4 specific objectives in regard to concepts and frameworks and to the current extent of this, and to examine some of the modalities and potentials and the motivations, and also to suggest some adjustments in the existing applied instruments. And I will return to some of these, or to all of these specific objectives during the conclusions. And the findings should assist the funding being invested more effectively, and as well as lead institutions and project developers to consider linking adaptation and mitigation in climate-related projects and activities as a trajectory to enhance the overall outcome of combating climate change. So the introduction, there is extensive scientific evidence that both adaptation and mitigation are essentially to address the problem of climate change. We can no longer go with just mitigation, and certainly not just with adaptation. But of historical reasons, we have this adaptation mitigation dichotomy where we are working in silos, or have been working in silos at least, in research policies and project implementation and funding. And this was mainly caused by the precipitation of the perception in regard to the similarities and distinctions between these 2 objectives. So, but there's a growing interest and a growing argument that we should link adaptation and mitigation that could bring substantial benefits at multiple scales. When I say linking, I mean to join or to couple, and also other terms that have been used are integration, interaction, or interrelationships, but are covering over the same idea. Today's focus is on agriculture and forestry, and the linking has especially been mentioned in these sectors, in the land use sectors and in the land use change sectors, as particularly evident to create these synergies. And they are also both very important in regard to mitigation and adaptation. Both of them, these 2 sectors together with land use change are creating or responsible for 24% of the global anthropogenic emissions of greenhouse gases. It was in 2010. And on adaptation, on the other hand, is also very important for both sectors, as both sectors are, but it's more 2-sided. Both sectors are very important in regard to adaptation of local communities, and both sectors are also in the need of adaptation to future changes. So this is a way of seeing it. The overall conceptualization for the study originates from the 4th assessment report by the IPCC in 2007. That was introduced this a chapter that dedicated to the interrelationships on adaptation and mitigation, and it's recognized the dual need for both and encouraged policymakers to express an interest in exploring the synergies and trade-offs between them. So it is an approach that they distinguish between the different 4 different types of interrelationships, and here I have shown it a bit other way but similar ways than they did in the IPCC report. We have the separate the separate measures up here. It could, for instance, where they are working in silos, they could be drainage improvement, or they could be energy saving. I have put a question mark here because we don't know what is actually going on between them if we are working in silos. Another way of seeing it is through complementarity, where they are linked as a cause-effect relationship, and there's an emphasis on is largely on a major-minor notion, where one of them is creating a co-benefit for the other one. So there's some kind of symbiotic fashion between these two, where they supplement each other, and the outcome is depending on the other one. Down here we have the trade-offs, or another way of seeing it. In some incidents we have a trade-off between adaptation and mitigation, and it can occur when interventions are implemented separately. It could be biofuel production that is having a negative impact on food security, and it could be fossil-fueled energized irrigation that is having a negative impact on mitigation. The fourth and last way of seeing these linkages are the synergies, and where there is some kind of overlap between them, and where there's an emphasis is placed on the system as a whole rather than on the isolated measures, and they have so-called win-win situations. It's like agroforestry, mangroves, climate-smart agriculture, land sharing through multifunctionality, and so on. And for this synergy to happen down here is a need for, there should be a resource-relatedness, which means that they overlap in the resources they are utilized in the system. And these overlaps I just mentioned, there's various perceptions in regard to the overlaps and distinctions between mitigation and adaptation, and we have in the past, especially, we have worked with mitigation as an international issue, especially for the North, with global benefits and long-term effects, and especially in the energy, transportation, industry, and waste management sectors we are working in. Whereas adaptation is a local issue, especially in the South, and it's giving short-term effects, and it's important in water, health sectors, and in coastal and low-lying areas. But what we have seen in the last 10 years or so is that this perception is vanishing, and a larger group of scholars have emphasized that this gap might not be as wide as perceived in the past, and they recommend a less sharp, a less categorical rendering of them. And for instance, that both are needed in the North and in the South, and no longer this divide in the spatial way of seeing it. So this is a concept that is followed in this dissertation. Yeah, the dissertation consists of, beyond this introduction, of 4 papers at various stages towards publication, and they address different questions, and they are also at different scales. Paper 1 is more a global paper, but still in the tropics. Paper 2 is on national district level, and paper 3 is on district and sub-district level. Paper 4 is on sub-district level, very locally. And then we have also a different emphasis in regard to agriculture and forestry, where paper 1 is both agriculture and forestry, paper 2 is forestry, paper 3 is agriculture, and paper 4 is focusing on something in between with tree-crop plantations. And I'm actually going to start with paper 4, the last paper, because that's the motivating force behind all the research topic, and the one I started with was to see the potential of a specific agriculture system to partake in a mitigation payment scheme, and thereby providing adaptation benefits in a shape of payment via ecosystem services. So in this system, we were looking at carbon sequestration potential in tree crop plantations, and it was going on in the high forest zone of Ghana, especially in this area around Kade. And it was looking at cocoa, oil, palm, rubber, and orange plantations, where we are looking at the potential for carbon sequestration in these 4 plantations. And we showed in the paper that the potential is present, especially in the rubber plantations, if they are established on land with modest carbon content and something like degraded forest or agricultural land. And beyond these crops, they could also produce some local benefits through increased income if payments are provided for these. We also showed that the simple measurements and simple monitoring were actually possible in these tree crop plantations, and therefore also a possibility for local people to participate in these payment schemes. But as we discussed in the paper, is that this could be difficult for these tree crop plantations to get into something like REDD+, as it might create perverse incentives like deforestation of primary forest to establish these plantations, and also have some negative impacts on biodiversity and soil erosion and water retention. So to obtain an overview and a status of the situation in linking adaptation and mitigation in agriculture and forestry sectors, I, together with C4, I made this study, which is a meta-analysis that is based on 201 project documents ranging from adaptation fund, adaptation action plans, and different adaptation schemes, and mitigation instruments and standards. So this is a map from the paper showing the distribution of these, showing the distribution of the projects that was included, and the top one is showing the distribution between mitigation projects and adaptation projects in Latin America, Africa, and Asia. And we both have mixed projects and agriculture and forest projects. Mixed projects are projects with both agriculture and forestry in them. And which we can see, what we can see up here is that for instance, there is a focus on mitigation and on forestry in Latin America, where there's a wider focus on agriculture and a more even divide between mitigation and adaptation in Africa. What we can see in the bottom is that they also use a wide variety of different portfolios. For instance, the AEF is the adaptation funds, CDM is the clean development mechanism, CCB is the climate, community, and biodiversity, and VCS is the voluntary carbon standard, and so on. So there's many different, we have 10 different portfolios in this one. But what we did was to search for statements in the project documents about contribution of adaptation and mitigation, and if these statements were substantiated. So this was done to investigate if mitigation projects clearly express their contribution to adaptation and vice versa. Beyond that, we also searched for outcomes from the described activities in the project documents in regard to adaptation and mitigation goals. And from the literature, we found 36 outcomes that could be where agriculture and forestry projects could contribute to that related to adaptation and mitigation. And we have something we call social adaptation, that's how it impacts communities, and then agriculture adaptation, ecosystem adaptation, and mitigation down here. This was done to see if there was a potential in the mitigation projects to contribute to adaptation and vice versa. So here are the results, and we have the mitigation projects over here, and then we have the adaptation projects over here. So what we showed in the paper was that a third of the mitigation projects actually have both explicit and also substantiated their contribution to the other objective to adaptation, and where it was only 5 of the adaptation projects that did that. Which was not that interesting. What was more interesting was that almost all projects we had, almost all 201 projects, they contributed to or had a potential to contribute to the other objective. The difference between mitigation and adaptation projects shall mainly be mainly explained by the different characteristics of the 2 objectives that we have. 36 of the 36 outcomes, we have 27 that is mitigation, and only 10 there's mitigation, and 26 there's adaptation. So there's not an even divide between the aspects we were looking for between the 2 objectives. So the conclusions were that the structure of the international climate policy and funding arenas, they make these the projects in the selected portfolios pursue adaptation or mitigation as a primary goal. And very few of the selected portfolios give project developers incentives or provide any guidance in integrating adaptation and mitigation. But despite this separation, we see there's a potential to address both goals jointly, and more have the potential to do so, even through that they are designed to only catch one of the objectives, adaptation or mitigation. And we also saw that potential was for integrating adaptation and mitigation projects were greater than vice versa, which was mainly explained by this difference in scope between them. So we recommend in this paper that should be put a larger emphasis on integrating adaptation and mitigation in the portfolio guidelines, and that could potentially create more holistic projects with complementarities and synergies, and reduce any trade-offs, but still without creating a forced marriage between them. It could, for instance, be to analyze the cost and benefits of considering the other goal or not in mitigation projects, to assess the climate risks and decide to integrate adaptation or not. This would also make the projects more accepted locally, which is important, especially in the case of land use projects in the developing countries. The 2 last papers, paper 2 and 3, is going on in Belize, and they are both case studies. For those of you that don't know it, Belize is located in Central America and bordering Mexico and Guatemala. And it's a very small country, only half the size of Denmark, and only around 350,000 people living there. But it's having a huge variety of ecosystems and a very high biodiversity. So it's been a place for many protected areas, almost 100 protected areas on such a small in such a small country in more than 150 management units, and they are all part of a greater system. They're running all the way from Mexico and down to the northern part of Argentina. So that's a huge playing a part in a huge system also. On the map, you can see that's the showing from the field work. Spent 7 months in Belize doing field work, and the red squares are indicating main location, base locations, and the other yellow, the yellow and the green ones are places that I visited doing the field work. The relevance of adaptation for Belize is that Belize is highly vulnerable to natural hazards like climate change, and is having a low-lying coastal area that is especially vulnerable to more intense and frequent tropical storms and hurricanes, flood damage, and rising sea levels. This is the high mountains. The rest of the country is quite low, and many of the places impossible to visit during many months. I was there because of flooding. And the country has also experienced frequent natural disasters, such as hurricanes, post-hurricanes, large-scale fires, which have huge impacts on GDP. The problem with the fires is mainly that they are mainly coming after the hurricanes. If you have a hurricane and the tree is left on the ground, then they have the fires the next dry season. The 2050 projections from IPCC for Central America is predicting increased temperatures and then decreasing precipitation, shorter rainy seasons and longer dry seasons, and also increased frequency and intensity of heavy rains and stronger hurricanes with increased disaster losses. And these things will of course also have a huge impact on the agricultural land and on the forest land. The relevance in regard to mitigation of Belize is, of course, globally, the emissions from Belize is unimportant, and Belize can hardly be held accountable for any of for climate change. But the expansion of agriculture in many developing countries contributes to climate change through deforestation and unsustainable land management practices. And it has been estimated that 92% of the emissions coming from Belize in the year 2000 was coming from land use and land use change. And it was especially driven by agriculture expansion, and secondary drivers was illegal logging and also legal logging and infrastructural developments. So the first paper from Belize is paper 2. You can follow the papers up here in the corner. And the first one is zooming in on from the 201 projects in the first paper, zooming in on 3 of the projects from that study, and they are all mitigation projects. They are all avoided deforestation projects. Avoided deforestation means that there's forest on the land, and the project is about protecting that forest. So by protecting that forest, you protect the carbon, and you have the possibility of selling this carbon as carbon credits. Beyond that, they also protect the high biodiversity and the watershed locally, of course. And then the project in the north here, Rio Bravo, is managed by an NGO, and the 2 other ones, Bull Run and Bowden Creek, are managed by private operations, and they are both managed by Americans that are living in Belize. What we can also see on the map is the green areas are protected areas or forest areas, and then we have the agriculture areas, and then all the small black dots are settlements, and a settlement in Belize is only 100 or 200 people living there. In the capital of Belize, in Belmopan, there's only 12,000 people living, so that's a very small. I think it's almost the smallest capital in the world. To analyze this, we used a multidimensional analytical framework, which was a refinement of the version applied in paper 1. And it was developed to explore the extent of which carbon forestry initiatives like these could integrate adaptation concerns in their design and implementation, but also to look for the motivation for including or excluding adaptation. So we were seeing mitigation projects through an adaptation lens. So we have these different, what they can contribute to in mitigation, but also to see what they're actually contributing to in adaptation, ecological adaptation, social adaptation, and agricultural adaptation. It can be funny that I'm looking also for agricultural adaptation in a forest project, but it's because of in the first 201 projects, we saw a lot of forest projects actually including agriculture activities to protect the forest areas as well. So this study was mainly, the analysis was mainly based on semi-structured interviews with the individuals directly or indirectly linked to the projects. as well as government officials and carbon standard managers. So the article findings are predominantly based on 43 semi-structured interviews, and the other interviews are giving contextual information and triangulating findings and enriching the discussion and so on. The questions given to the informants was related to the framework. So they were asked, for instance, how this project was reducing or how it was handling the human influence on the projects and so on. So here are the results, and the one in the figure here in the left bottom is illustrating which of the aspects, the analytical framework up here, which of the aspects they actually are contributing to, or which of them they are included. So the black ones, they indicate that there's a direct or clear presence of the aspect in the project, and gray ones indicate that there's an indirect or weak presence in the project. And the blank ones or the white ones indicate that it's not been considered in the project. So what we can see is that, first of all, that all the projects are contributing to carbon losses in forests, so they're trying to reduce the carbon losses in forests. So there's no, they're all the same in terms of that. And then if we are looking at the ecological adaptation, yeah, all three of the projects are actually contributing quite nice to that one, or have some consideration of that. And that's mainly because of that they are avoided deforestation. Many of these things that are included in the ecological adaptation, for instance, the ecosystem connectivity, is covered simply by being avoided deforestation. So it's not an activity that is in the project, but it's by being avoided deforestation project. Another one down here in the two of the projects is climate change management, and it's only weakly covered. It's covered by fire management practices such as building and maintaining a fire tower and so on. And then all of them, they have their main activity in this one, the human influence, and that's about protecting the forest areas by patrolling the area. If we are looking at the other ones, how they are contributing to social adaptation, which is the one in the middle, we can see they only contribute to, all of them only contribute to 3 out of 10, and they are weakly covered. And they, for instance, all of them contribute to diversification by giving jobs to local people, by employment related to monitoring, patrolling, and construction. And then all projects also contribute to education by giving environmental education to the local staff and providing scholarships and other things related to education. And last, all projects, they contribute to this one, which is water and energy, and they contribute to protecting the local watershed, but that's mainly related again to being an avoided deforestation project. So beyond these findings, we asked, I asked the interviewees to suggest a number of initiatives that could be implemented in the projects to enhance the linking of adaptation and mitigation. So here are some examples of the things that are actually disregarded synergies or complementarities in the projects. That could be, for instance, fire management of the slash and burn system. All around all 3 of the projects, you have slash and burn systems where the project developers could include some fire management, which would reduce the risk of uncontrollable fires that are escaping into these areas every year. Another activity that could include was to promote agroforestry in the buffer zones, which would impede the access of to the protected areas and also increase biodiversity, and beyond that also sequester additional carbon. And the third one here is that they could also assist farmers in securing land tenure. in the current system, large-scale mechanized farmers are buying the land from the small farmers, and that is having a greater impact on the protected areas compared to the small-scale farmers that are normally using long-term fallow and so on. And in regard to the ecological adaptation aspects, they could do some replanting to maximize the genetic diversity. The problem is, after both fires and hurricanes, is that some of the species are stronger than others, and if you don't replant, you will in some places have systems with lesser species, which makes the forest more sensitive to insect and disease attacks. Last example mentioned here is the increasing the collaboration with the local communities, which could avoid illegal encroachments of the areas, which are illegal loggers that are removing important seed trees as they are taking the larger trees out, and they also impact the biodiversity by doing that. So the conclusions from this paper were that it is demonstrated that adaptation and mitigation in these projects can potentially be linked to create a stronger link between adaptation and mitigation, and it could promote more climate-friendly rural development and enhance mitigation and increase ecological resilience. But the link in these projects has proven very elusive, and yes, the ecological adaptation is covered by being implicitly part of being an avoided deforestation project, but the social and agriculture adaptation aspects are largely ignored in these projects. And the projects can also be contested by the local communities in regard to property claims and food security concerns. And this is mainly caused by the nature of the carbon markets and the standards, and which is focusing exclusively on mitigation aspects and largely ignoring adaptation concerns and dimensions. So the project developers do not have many incentives to pursue a stronger link to adaptation, and they also lack resources and capacities to deal with both dimensions. Beyond that, we also show in the paper, which I have not mentioned until now, but that the additionality is very contested, which is why the projects mostly provide non-carbon benefits such as biodiversity and watershed protection. So what I'm saying now is that we're having a carbon project that is not delivering any mitigation and nor any adaptation actually, which is quite interesting. Last paper, to say it nice, yeah. Last paper is we have moved down to the southern part of Belize, to the Toledo district, which is in all statistics the poor part and the overseen part of Belize, and it's where the Mayan Indians are living. 80–90% of the population in that area is Mayan Indians. And what we can see on the map out here is the green areas are both forest, and some of them are protected areas. And then we have the agriculture in between. And all the asterisks are small Mayan villages. And we can see we have a few along the highway that are not Mayan villages. But all the other ones are 100% Mayan villages. And this study was about investigating the barriers of linking adaptation and mitigation in smallholder farming system here in the southern part of Belize, and especially with the focus on the cultivation of maize. And it's based on qualitative interviews in the villages and with organizations working in the villages and with government officials or government agencies also. So it was to suggest adjustment of this maize production, which is slash and burn, suggestions that are expected to have both adaptation and mitigation benefits, and see if there's any barriers in making these adjustments. Barriers here is the factors that make it harder to plan or implement actions or that restrict options. So just some pictures. It's 40 villages that are spread over a large area, and they are looking like this, where the houses, there's a white space between the houses, and this is the normal system in cultivation maize, where you slash and you burn it, and then you plant the maize in the end of the dry season. No, just before the wet season, and then in the end it will look like this. This is the local variety, around 3 meters high, so it's very high crop type of maize. And the problem in regard to mitigation is that this is a very extensive way of farming, so it's using a lot of land compared to maybe more efficient ways of farming. In regard to adaptation issues, these ways of planting are very vulnerable to wind and hurricanes, and also to the change in seasonality, because you're very dependent on when to plant, because you have to plant when the rainy season, just before the rainy season starts. And this planting system is also vulnerable to heavy rain, which create erosion of topsoils, and we already see now declining yields, and which is because of nutrition deficiency and some of the other things just mentioned here. So one way of changing this in the paper, I suggest 4 different adjustments. I'm just going to mention one of them. And this is a schematic presentation of one of the systems, which is called alley cropping, where you have the maize in alleys. That's why it's called alley cropping. And the main idea is to return the nutrients to the maize, and then you can cultivate again and again on the same place, so you don't have to move around, or at least with a shorter fallow in than compared to the normal system. And this should reduce deforestation in the area. And this is how it looks like in real, where you have the maize in the middle and the trees on the side. This is just how it's presented in the paper, where we have the alley cropping as an alternative to slash and burn. This is the description, but the most interesting part here is the adaptation effects and the mitigation effects. So it should be a system that is providing both adaptation and mitigation benefits, and we also have some negative feedbacks, but mainly have some positive impacts on the system, on adaptation and mitigation. So this is a system that is already implemented by one of the local NGOs with around 15 farmers that have adopted this system successfully, but they have not spread out to the other communities. So it was to see what kind of barriers there are in changing some of these systems. Yeah. And then we have the 4 different adjustment techniques, and one of them out here is the alley cropping, and this is the magnitude of change. So this is just crop rotation, that's a small change, and alley cropping is a major change. In the middle, I have the different barriers that are mentioned in the paper. I'm only going to talk about the land tenure here, but they are all mentioned in the paper. And then we have the institutions over here on the right side, and going from global institutions to local institutions, how they are impacting on the barriers. So the interviewees, they revealed several barriers in making these adjustments, which are listed here. And this is an attempt to illustrate the complexity of making these adjustments. And for instance, the alley cropping system, the problem is now with the land tenure is that normally you have the maize planted on the reservation land. Reservation land is land that is belonging to the village and something that you normally not plant trees on. So if the cacao production and orange production is outside the reservation land, so that's on leased land normally, because there's a dislike in planting trees on the reservation land because that is removing land from the community pool. So that's a problem for alley cropping because that's a system where you plant trees, but if you do that, you remove land from the community pool, and there's cases where people had planted orange trees on community land, and the day after all the seedlings was gone, just taken up by people that there was a dislike in the community about doing this. So people don't do that. Other links to alley cropping can be mentioned here. There's a lack of technology. There's that's concern with seeds to these to the trees, and also there's a link to the culture and other things mentioned in the box down here. That's because the changing to alley cropping will require increased labor input and also increased interest in making these changes, which most farmers are not willing or able to provide. On the right side, we have the institutions, and the only one that can change the clear land tenure problem is the national government, but it cannot do that without collaborating with the international development institutions that are working for Mayan rights in Belize, and also the local NGOs working with agriculture and also working with Mayan rights. And then we have the local governance with the village leaders and so on. So it's a highly complex system in making these changes. Just last week there was several arrests in this area because of problems with land tenure, and one of the leaders of the Mayans Alcalde Association was actually arrested. So there's not a huge agreement from the national government with the local NGOs on how to handle land tenure in that area. Another way of seeing this is looking at the local differences between the villages, and local differences in regard to attitude and responses in the face of changes. And for instance, one of the villages, Halakte, down here, is a village that are simply doing nothing to adapt. They are using unsustainable farming methods with chemical inputs, and with soil depletion as a result. And then we have Kongsager, which already have changed their planting system a little bit. They actually have changed from being very dependent on the weather pattern to plant in the dry season instead, which of course is giving a lower yield, but it's a better system for them even with the lower yield. And then we have San Jose, which is a village that have changed a lot to cacao production instead of being solely dependent on the maize and other crops they have in the village. And the last one have transformed tremendously by moving to the highway. That's actually people from Kongsager that have moved all the way to the highway to get an easier access to jobs, and are now less dependent on agriculture and forestry. So the conclusions from this paper was that the adjustments to enhance the link between adaptation and mitigation in a small-scale maize production system in these Mayan villages is actually possible, but several barriers are present to make this overall climate-smart objective possible. And these barriers are existing at different spatial scales, and they are also occurring at different governments levels, which is calling for a more mainstream way of implementing the objectives, adaptation and mitigation. And it was also shown in the paper that these barriers are far from uniform across the villages and households. And it was also mentioned that some of these also could create trade-offs, for instance, in regard to food security when forest land is spared. So the overall district level strategy for enhancing the link between adaptation and mitigation is actually possible, but the toolbox should contain a wide variety of approaches, which is very different from how the extension officers in the region is working now, where they normally only have one opportunity to work with. Just before the overall conclusions, I will shortly return to the conceptualization because there are different types of linkages that were addressed and investigated in the papers. And this is, of course, very confusing to look at. But paper 1, we are mainly looking at separate measures and trying to see the potential to actually move to complementarity or move down to some kind of synergy in these measures. In paper 2, it's 3 mitigation projects and how could they actually be moved to deliver co-benefits or also to with synergies, for instance, in agroforestry around like in the buffer communities and so on. In paper 3, it's a system, agriculture system now that's having some trade-offs, and how can you, with adjustments, move that to create synergies. And then paper 4 is what we can call an adaptation measure, where we actually have some crops that is producing some adaptation, and then we could move that to some kind of synergy by producing mitigation as well. Paper 2 and 4 is also mentioning some of the trade-offs that are present in the different systems. Last slide. The overall conclusions, here I will return to the research objectives. And the first one was to explore and elaborate on the concepts and frameworks and to demonstrate the research gaps in linking adaptation and mitigation. This dichotomy I talked about in the beginning, yes, that's still present, but it's mainly a politically and scientifically constructed one. And there is both spatial and temporal overlaps present in the system, especially in the system where in this one where agriculture and forestry, but other sectors that also can be mentioned is building and urban planning, but we also have different sectors where it might not be the greatest idea to link adaptation and mitigation. Furthermore, there's a need for development of concepts and frameworks that are operational and can investigate and evaluate different connections that exist between adaptation and mitigation in the areas who have the greatest overlaps. And there's a need to study the government mechanisms that are most effective in fostering the linking between adaptation and mitigation at multiple levels, and for empirical studies that demonstrate the robust criteria and indicators that can help to establish a greater understanding of the many practices and processes involved, because their interactions now and outcomes of the different activities are not predictable, which is making it difficult to determine the possibilities of synergies and to avoid trade-offs. The second one was to examine the extent of linking adaptation and mitigation in the current agriculture and forestry projects globally. And the results from that was that the land use projects in the tropics have this major-minor notion where there's a focus on adaptation or mitigation, and this is highly related to the above-mentioned dichotomy and is therefore driven by the specific interest of the international donors and the national institutions that construct the frames in these projects. But by strictly complying with these institutional standards, where projects might overlook these synergies and complementarities and also create trade-offs. The third one was to examine the modalities and potential and motivations for linking adaptation and mitigation in agriculture and forestry activities. And it was shown that there's very few incentives actually, and for project developers and also guidance in the portfolios to actually to create an integrated system between adaptation and mitigation. And it was therefore recommended that it was to make it mandatory to assess if benefits of integrating the other objective could prove the efficiency of climate funding in general and delivering joint benefits. It was also shown, mainly in the last paper, that there are barriers, and the barriers are not only linked to the institutional setting, it's also linked to other things that are going on that are present in societies. And also it was also shown that the adjustments that are supposed to happen in these by implementing these projects are occurring in highly complex systems. The last conclusion or last sub-question was to suggest adjustments in the existing applied instruments to address the linking of adaptation and mitigation to enhance synergies and to avoid trade-off. It showed a need for creating these incentives for linking, especially where there are overlaps and resource relatedness. And if these incentives are not put forward politically and financially, it can create inefficiency, and we may find ourselves following approaches that solve one issue and increase others. It was also shown that the current carbon markets with project standard certifiers, developers and auditors, especially in the forest sector, was unlikely to deliver both mitigation and adaptation, and it was suggested to shift the focus to policy programs that support fair land tenure regimes and promote sustainable resource management practices, and also to enhance community-based natural resource management. Thank you, and thank you to my financial supporters.
Thank you very much. We will have a short break, so please be back 2:10.
Hvor lang tid tog jeg?
En time.
En time.